In this short video, we're going to look at the last two topics that come up on Revision Test 2, foundation level, and that is, the two topics are algebra and probability. Okay, let's get on with the show. Algebra. The last few questions involve you simplifying. Just bear with me. There's the word. And then you're given some expressions, just make it a bit bigger, to simplify. Here's one example, 6 times t times 3. How do you simplify that? Well, this involves multiplication, and the way you do it is this. Multiply any numbers that you have in your expression. An expression is just lots of numbers, letters, and times, and plus signs, and what have you. That's what I mean by an expression. Multiply those together. Use a calculator if you're not sure. 18, and then add any letters that were involved. There you go. 18t. 6 times 3 gives you your 18, and the only letter involved was a t. But let's look at division. What about 15 cubed divided by 5? Well, it's very, very similar. But instead of doing the multiplying first, we're going to do the division first. 15 divided by 5 is 3. And then add any letters that you had involved. So the answer would be Q. Let's try that again. Here you go. Say you had 20m all over 4, and you want to simplify that. Well, you deal with the numbers first. What is 20 over 4? Now, there's a very strong link between division and fractions. They're near enough the same. So there's two ways of doing this. You could do, and I would advise you do, you just type in the fraction involving the numbers. 20 over 4 is 5. Or if you haven't got this type of calculator, do 20 divided by 4, and you get the same answer, 5. And then, as I say, all you have to do at the end is just add any letters involved. And the last one I want to simplify is, well, we've been looking at multiplying and dividing. Let's looking at adding and subtracting. Here you go, 6x plus 2y minus 3x minus 7y. Now, the thing to remember here is you can only add x's together. The technical term years ago was called collecting like terms. So we can only deal with the x's together, only they can be combined or collected, and the y's are a totally separate term, and only they can be collected. Now what does it all mean? Well, it means we're going to work out firstly what is 6x take away 3x. So 6 take away 3, deal with the numbers first, is 3. But when you're adding and subtracting, because you can only be dealing with the same letter, you only ever add just the letter in one of the letters involved, okay? So 6 take away 3 is your 3, and then we were dealing with x's. So you just put 1x there. What about the y's? Let's deal with those. What did we have? We had plus 2y take away 7y. So I'm going to deal with the number bit first. Plus 2 take away 7. Plus 2, let's just clear it. Plus 2 take away 7 equals, there you go, minus 5. So the number part of my answer is minus 5. And then, well, can you see what mistake I've made? Deliberately. Why? No, when it comes to adding and subtracting, because the letters have to be the same, you only just add one of those letters. So it's minus 5y. So how do I finish off my answer? Well, I write this. I write that this simplified becomes 3x, remember the first bit of working we did, take away 5y. There you go. Right, now, let's look at probability. There's a lot of information here, so let's just run through this slowly. Alice has 14 sweets. 7 are red, 2 are blue. 1 is yellow, and the rest are green. Use these words Using these words, complete the table below. Evens, impossible, likely, unlikely, certain. Well, before we can go any further, we're going to write down the probability for each of the types of sweets. That is the red ones, the blue ones, the yellow ones, can you see that yellow? And the green ones. But there's one thing we haven't actually, let's just go back, let's look at this question here. What have we got? We've got 7 red. We've got 2 blue. We've got 1 yellow. They haven't told us how many green, but they have told us that there are 14 sweets. So what I would have to do is, I'd take away the number of red sweets, then I take away the number of blue, then I take away the number of yellow to find out the number of green. There are 4 green. Right, let's work out the probability. Now this is important. It'll come up especially next year when you move on and look at harder questions on probability. We're going to write them as a fraction, because that's the easiest way to do it. And here's how you write it as a fraction. You take the number of the colour you're dealing with, so there are 7 red, and then you put it over the total number of sweets. There are 7 out of 14 red. Let's go through it with blue. There are 2 blue sweets, so the probability of getting a blue is 2 out of 14. What about the probability of yellow? There's only 1 yellow sweet out of a total of 14. And because of the extra work we did, we can work out the probability of green. It is 4 out of 14. And you can always double check the top numbers. 7, add 2, add 1, add 4 should all add up to, when you add them all together, should give you the bottom number. 7 add 2 is 9, add 1 is 10, add 4 is 14. Yeah. Now, using these words, complete the table below. Before we go any further, the best way of dealing with this type of question, evens, impossible, likely, unlikely, certain, is to change each of those ones we had above into decimals. Now it gets a bit tricky. So, the probability of red is 0.5. What about the probability of blue? 2 out of 14. What's that as a decimal? Oh, that's not very nice. We'll call it 0.1. We'll just round it to 1 decimal place. That should enable us to answer this question. What about the probability of yellow? It was 1 over 14, wasn't it? And that becomes 0. Well, what's that to 1 decimal place? Well, it's 0.1 again. And the last one, 4 out of 14. Let's do that. 4 out of 14 equals 0. We'll call that 0.3. It's closer to 0.3 than 0.2, isn't it? Now, let's answer this question, or these questions. It is blank. He chooses a red sweet. Well, these words, evens, impossible, likely, unlikely, and certain, are associated with these decimals. If something is evens, its probability is 0.5. If something is impossible, its probability is 0. If something's likely, it's bigger than, we'll come back to that symbol here, it's bigger than 0.5. If it's unlikely, it's less than 0.5, and if it's certain, it's 1. So let's now see if we can work out what words to put here. It is blank, he chooses a red sweet. What's the probability he chooses a red sweet? 0.5. So that word is evens. What's the probability he chooses a green or a red sweet? Well, the way to work that out is you add the two together. This is getting quite high level now. The green add the red sweet would give us 0.8. Now, that's bigger than 0.5, so the word we're going to write down here is likely. If the probability is more than half, it's likely. Now, it's a tricky one. He does not choose a blue. That means he could choose a red, a green, or a yellow. Add those all up. 0.5, 0.3, and 0.1 is 0.9. That's very likely. So the word here is going to be likely again. Just run through that. He does not choose a blue. That's a very short way of saying he chooses any of the other ones. That is a red, a yellow, or a green. And finally, the probability he chooses a white sweet. There's no white sweets, so it's impossible. Okay, let's look at the last bit of probability. This is quite a tricky question, I think, but I reckon we're up to it. Alan has 10 sweets in a bag, and there are 4 colours. Red, blue, orange. I haven't got an orange. Tell you what, orange is, I'm just going to use black for that, and the letter O, and yellow. But there's some more information. It's evens, he chooses a red. Immediately we can say that. That means half the sweets are red. So there's only 5 more sweets left in the bag. If it's evens, there's the same chance of choosing it as there is not choosing it. So it's half however many things you have. It's very precise, the word evens. It is more likely he chooses a blue than an orange. So there's going to be more blue sweets than orange. And finally, the chances of choosing a yellow are the same as choosing an orange. Let's just get rid of that. It's a slight typo. That means the number of sweets that are orange must be the same as yellow. Can we work out what the other sweets are? Well, we'll do it by trial and error. Does this work? Let's say 4 of the sweets were blue. I would only have 1 more sweet, so I can't have orange and yellow each having 1, because that would make 11 sweets, so I can't do it that way. Let's try the next number down. What about 5? Or the next number up, 5. Well, I can't choose 5 because then definitely there's no other colours. There's no orange and no yellow. So I've got to go in the opposite direction. I've got to go to 3. Let's try 3 blue. And that would then give me 2 more sweets. If I made both of them orange, no, that would mean there's no yellow. I can't do that. If I made both of them yellow, it would mean I had no orange one, so I can't do that. But what I could do is make both one of the sweets orange and 1 yellow. Let's check. Does that work? It adds up to 10. There is more blue sweets than there is orange and yellow, so there's more likely to choose a blue than an orange. And also the probability of choosing orange and yellow is the same because there are the same number of sweets. So that's how you deal with one like that. Use the key bit of information that it's evens to halve the number of sweets. And then if something's more likely, there must be more of them. And if there's the same likelihood, just as likely, or the chances of choosing are the same, there must be the same number of sweets. Okay, I hope this has helped in some way. Thank you for listening.